Today we're going to begin talking about functions. Before we get completely into functions, there's some things that we need to review before moving forward. One of those things is an ordered pair. Now, you've been working with ordered pairs for a very long time, and an ordered pair is two numbers that you graph on a coordinate plane. So here we have x and y. And your ordered pair is always listed with the x first, comma, y. Now when you graph an ordered pair, you graph it on the coordinate plane. And the coordinate plane has an x-axis, which is down here, and the y-axis. The y-axis is vertical, up and down, x-axis is horizontal. So let's say we have an ordered pair 2, 5. You always start with the x first. You graph the x point first. And some of you remember it's like a plane taking off from here. You have to go drive on the runway before you could take off into the air. So first we're going to graph 2. So we start at 0, which is this point, 0, 0. And we're going to go over 2, and then we're going to go up 5, because 5 is our y. So that's going to bring us here, and this is our ordered pair, 2, 5. The next thing we're going to review is an input-output table. Now, these you've been doing for a while. Input is the number you start with, and then you have a rule that is applied to the input number. So here our rule is 3. So if we input 1, the output is going to be 1 plus 3, which would be 4. Here our input is 2, we're going to add 3, so our output is 5. And this is called an input-output table. The last thing we need to review is a coordinate plane, and I mentioned this a little bit earlier. Coordinate plane is where you graph your ordered pairs. Now the coordinate plane has 4 quadrants, and you start here as the first quadrant, so this is 1, 2, 3, 4. One of my students once told me, think about writing a big C starting on the coordinate plane to help you remember where you start. So if you start here and draw your C, you know that this is 1 and you're going in the counterclockwise direction. Also note that your coordinates of your ordered pair are positive, positive in the first section, positive, negative in the second quadrant, negative, negative in the third quadrant, and positive, negative in the fourth quadrant. Now, what does this all have to do with functions? Well, an input-output table represents a function. And what is a function? Well, a function is a relation in which each input is paired with exactly one output according to a specific rule. A function can be represented by ordered pairs or a mapping diagram. Let's see how that works. So remember, to graph these ordered pairs, we start with the x first, which is 0 for this one. So 0, 1, 1, 2, and 2, 4. So our ordered pairs are here. We've graphed the function here. And you can see as each x or input increases by 1, the output increases by 2. So our rule for this would be increasing by 2. So now how do you go from ordered pairs, which are here, to a mapping diagram? Well, it's simply just putting it into an input-output table. So we have our input, which is also our x's, and our output is our y, if you think about an ordered pair. Here, 0 is matched with 1, and here we have 0 and 1. To show that it's an ordered pair, it goes together, you need to have an arrow pointing from the input to the output. And I'll show you why that's important in a minute. So let's do an example. This question's asking to draw a mapping diagram of the following ordered pairs. So we want to draw an input-output table. And remember, output is Y and input is X. And we are going to list all the inputs and all the outputs. You want to list them in order. So we're going to start with -1, 2, 3, and 5. Those are all of our X's. Now we're going to list all of the Y's. Again, you want them to be in chronological order, so either in increasing or decreasing order. So if we start with -1, the next number that should come is not 6, but 5. So 5, 6, and 9. Now remember I told you before, I'll tell you why those arrows are important. Well, those arrows are important because now you need to show which input is matched with the output. Because according to here, if we just look straight across, it's showing that 2 is matched with 5. But that's not actually accurate because the 2 is matched with the 6. That's why we need the arrows to appropriately show which input is matched with each output. So this input-output table shows exactly which input, the X's, is matched with the outputs, the Y's. And they are the same as the ordered pairs listed up here. This is another kind of example you might see with a mapping diagram. It's asking you to describe the patterns of the inputs and outputs. And this is very similar to the sequences that we've already done. So you want to look at the pattern between the inputs and the outputs. So on the output side, each is being increased by 1. On the output side, each is being increased by 15. So as a rule, or describing the pattern, you can say as each input increases by 1, the output increases by 15. And that's the pattern that this mapping diagram is showing. Okay, here's your first on your own question. Draw a mapping diagram of the following coordinate points. Remember to use arrows, and you're drawing an input-output table like this. And here's your second question. Describe the pattern of inputs and outputs in the mapping diagram. So first you want to find the pattern and then write it similar to the way that I did in the example, as each input blank, the output blank. And things to remember. Input-output is the same as an ordered pair, X and Y. List the numbers in order, so whether they're in increasing order or decreasing order. Use arrows to show pairs, and input-output tables show functions.